All right, this is Mrs. Query, and this is the solutions video for quiz 1.2 to 1.8. So the first one is the product of two and four more than a number. So the product right here is a multiplication, and we're going to multiply two things, right? We're going to multiply two. Let's try that again. We're going to multiply 2 and 4 more than a number. So let's write that. So I have 2 times 4 more than a number. I'll just use x. Okay, and then I have is less than 20. So here is the product, so multiplication. Here is 2, and then here is the sum of 4 more than a number. Okay. And then we have to do a couple things. First, we had to write the inequality, which I just did, and we need to solve the inequality, and then I need to graph its solution set. So I did one part of this problem. Now I need to solve for x, and the first thing I'm going to do is divide both sides by 2, and I will get 4 plus x is less than 10. Then I'm going to subtract from 4 and 4 from both sides, and I would get x is less than 6. And then I will make a number line. I have an open circle since it's only less than, there's no equal, and it's less than 6, so I have to move to the left. Okay. Alrighty, solve the inequality and graph its solution on a number line. So we need to solve for x, and I'm going to move x to the left-hand side. So I'm going to subtract 4x on both sides, and I will then add 11 to both sides, and I will get minus 10x is greater than or equal to 30. I will then divide by negative 10, and I will have to remember that when I divide by a negative number, I have to switch the inequality symbol, and I will get x is less than and equal to a negative 3. So that rule applies to when I divide or multiply each side of the equation by a negative number. And so then I will draw a number line. I will have negative 3, negative 2, negative 4. It is less than or equal to, so that means I have a closed circle, and my number will go, or my arrow will move to the left since the solution set is smaller than negative 3. Okay, moving on. The number of students attending a small high school has varied over time. Historical population data for this school is given in the following table. What is the average rate of change of the number of students attending the small high school between 2008 and 2017? And interpret this rate in context. We're going to have to determine the slope. That's what they're asking for, the average rate. And they wanted to know number of students per year. That's kind of what they're looking for. And the reason why I wrote that is because slope is rise over run. And what this does is tell me which one I need on the top and which one I need on the bottom. So the other thing you have to be very careful of is to pay attention to the year in which they want. So 2008 and 2017. So they want to know the average rate of change between those 2 years. So I will then calculate a change in y over the change in x. Well, what is my y? My y is number of students. So number of students is 380 minus 419 divided by what is on the x-axis. It's the years. So that would be 2017 minus 2008. And that value will end up being a negative 4.33. And so I found the average rate of change, but I have not answered the question, which is the part that most people probably struggle with. Interpret this rate in context. So if you recall from the notes, there was kind of like a template. First thing that you want to do is write the number of talk about what it is we're trying to describe, which is the number of students attending a small high school, okay? And then we're going to have the word decreased or increased. That was the template that you were given. And how do I know if it was decreased or increased? Well, I know, by the way, I forgot my units over here. 4.33 students. Students per year. So it decreased because it was a negative number. Decreased at an average rate, so that was kind of that phrase that we wanted to use, of, and then this number we're going to pick is always positive, okay? Because you took care of the fact that it was negative because you described it in a decreasing fashion. So if you were to say decreased at an average rate of negative 4.33, it's like a double negative, okay? So it decreased at an average rate of 4.33 students per year, and then you got to give the range from 2008 to 2017. So there's kind of like that form. So you have to describe what you're talking about, which is the number of students in a small high school, and then increase or decrease. This case it decreased at an average rate. There's that phrase that you're going to use every time of whatever your value was, 4.33, and then provide your y over x, y being number of students per year. So those are your units and then the range, okay? Okay, write an equation of the line in a slope-intercept form. Slope-intercept form, so that is y equals mx plus b. So that's what our slope-intercept form is. And that passes through the points 3, 4, and 6, and 5. So x is 3, y is 4, x is 6, and y is 5. Now I have this little thing that I do, and I do this because I make silly mistakes. So I actually will, it doesn't matter which one you call y1, which one is x1, y1, which one is x2, but once you have it picked out, then you will maybe be less inclined to make a mistake, okay? So y2 minus y1 is equal to 5 minus 4 over 6 minus 3, and that will be equal to 1/3. And now I know the slope. So I have my y equals 1/3 x plus b. And then I need to pick one of these points. I'll just pick 3 and 4 and plug it into that equation and solve for b. I'm getting closer. So then I will say y, which is 4, is equal to 1/3 times x, which is 3, plus b, and I can solve for b now. So I find that b is equal to 3. Now I have everything I need to give you the equation for a line. So I get y is equal to m, which we solved to be 1/3 x plus 3. Write an equation of a line in slope-intercept form. What am I doing? Y equals mx plus b. That we're going to write it, we're going to find this line that's parallel to this line. Okay, y equals 2/3 x plus 1. Well, if it's parallel, what do we know about the slopes? So we'll call this equation 1, and then we'll call equation 2 what we're looking for, and we know that the slope of equation 1 has to equal the slope of equation 2. That's the definition of parallel. They have the same slope. So I know the mystery equation slope is what? So we know the slope is 2/3. Okay, and I was told that there are these 2 points on the line. So there's an x that's on the mystery line, and there's a y. And so I am going to then use those values. -12 is equal to 2/3 times x, which is 6, plus b to find b. Because then if I have the slope and I have b, then I'm good to go. And let's see. I just find that I have negative 12 equals 12 over 3 plus b, and then I will solve and I will find that b equals negative 16. And so once I have that, I can say y equals 2/3 x minus 16. And there's your equation for your line. Okay. Okay. Moving on. Solve the system of equations by substitution or elimination. So I'm going to do elimination by multiplying both of them by a number so I can cross something out. So I'm going to multiply, I'm going to eliminate my y's. So I'll multiply this entire equation by 5, and I'll multiply this entire equation by 2, because if I do that, the value of y will be 10 in both of them, and they actually works out great because one's negative, one's positive. So I have to multiply every single term in that equation by 5, and I will get 15x minus 10y equals a negative 5. Then I will get 8x plus 10y equals 28. And notice the signs on the y are opposite. Now I'm just going to add the two equations together. And what happens to y? They drop out. So I get 23 times x plus 0, right, is equal to 23. And I will divide both sides by 23. And I will find x is equal to 1. Now that's only one part of the equation. So I've got to now find y. What is y? And I will take x equals 1, and I will plug it into either one of those. It doesn't matter which one. And so I'll just pick the first one or maybe the second one. Doesn't matter. So let's use the second one. So 4 times 1 plus 5y equals 14. And then I will subtract both sides, or 4 from both sides. And I will get 5y equals 10. And then I will divide by 5 on both sides. And I will get y is equal to 2. So solve the system of equation. What is the answer? Y is equal to 2, x is equal to 1. So you could write 1, 2, and there is your answer. All right. Next, solve the system of inequalities by graphing. So in order to graph an inequality, the first thing I want to do is get it into a y equals something form. So I can have a y equals mx plus b form. The only difference is it's an inequality instead of an equation, or an equality. Okay, so I'll take this first one and I'll subtract 3 from both sides, 3x from both sides, and I will get, let's see, I will get negative 4y less than negative 3x plus 8. Now I'm going to divide both sides by negative 4, every single term, and I will get y, and because I divided by a negative number, I have to flip this symbol. So is greater than 3/4 plus a negative 2. So I'm just going to subtract, I forgot my little x, minus 2. Okay, so there's the first equation. And then let's do the next one in red. And I will subtract 2x from both sides, and I will get 5y is greater than or equal to negative 2x plus 15. I just like to keep my x's first, sorry. Then I'm going to divide by a positive 5 of each item, and I will get y is greater than negative 2/5 x plus 3. Okay, and then this last one here is already in the form that I can graph. So now I got to start graphing. So I've got to pick some points. I'm gonna first graph equation 1. I'll call that equation 1. Let's make that clear. Equation 1. So I have, can I use 0 as an x value and have something that is convenient? Sure enough, if x is 0, y is negative 2. And so I need to go and find that location. So I go to x is 0, y is -2, and I put a dot there. And of course, my pen's always acting up on me. And then my slope is 3/4. So 1, 2, 3, 1, 2, 3, 4. And then I have to decide whether or not it's an open or a dashed line or a solid line. And because it's just greater than, it is a dashed line. And then this is Mrs. Query's little trick I do. I have a little symbol that I know it's greater than. So I'm going to go above that line. And then I have to graph the next line. So I'll look at the one that's in red and I say, can I use x equals 0? And sure enough, I can. If when x is 0, y is a +3. So I go to my 0, +3. My slope is -2/5. So I'm going to go down to over 5. There it is. And then I have 2 points, and then I have to say, is it solid or is it dashed? But because it has an equal then, I have a solid line. Now let's see if I can do this. Okay. And then I say, okay, well, it's greater than, so I'm going to be above. Okay, then I go to the next one, and I'll do that one in green, and y is less than 6. So I come up to 6. I draw a line. Oh, and notice I drew the wrong line. It's not less than or equal to, it's less than. So it has to be dashed. And then I notice that I have to be below it. So above the red, above the black, below the green. This is my region of my solution. Okay, good. A group of 10 people went, let's see, did I finish the whole problem? Solve a system of equation inequalities by graphing. And I have completed the problem. I generally recommend making sure when you finish a problem, especially if you have time, reread the question, make sure you answered it. A group of 10 people went to the movie theater. So I have 10 people. At the movie theater, student tickets cost $7 and adult tickets cost $11. I know that I have 10 people. I know the cost is $7 for a student, and the cost is $11 for an adult. If the group spent $94 on tickets, something's going to equal 94, I have a feeling. How many adults' tickets were purchased? Okay. Well, I have 10 total people. So let's call this an S value, and this is an adult value. I know that between my students and my adults, I have a total of 10 people. Okay. And I know that the student costs $7. And so however many number of students I have, I got to multiply times 7. Plus, I know that the adults cost $11, and however many number of adults I had has to cost 11, and that equals 94. And so we want to then solve. So I'm just going to kind of clean this up a little bit. And so that 7s plus 11a is equal to 94. And I know that s plus a equals 10. I have 2 equations, 2 unknowns, and now I can solve them. I could do it by elimination and or substitution. So how about we multiply the bottom one by a -7, and that would give me, I'll just do this in red, -7s minus 7a equals -70. And now we need to add to it. So add to it those 2 equations, and the s cancels out, and I will get 3a equals, well, that would be good if Miss Query can add 7 and minus, or -7 and 11. So I get 4a is equal to 24, and I find that a is equal to 6. And then I will plug that back into maybe this equation over here. Let's say s plus 6 equals 10. I find s to be equal to 4. but that's actually not what they asked. They asked for how many adult tickets were there. There's your answer. Okay, continuing on, find the minimum value of the function f of x is equal to 5x minus 2y given the following constraints. Okay, so the first thing we can do is graph x is greater than or equal to 0. So if x is greater than or equal to 0, it always has to be to the right of 0. So, and it's greater than or equal to, so I have a solid line. The next thing I need to write is graph this next inequality. And I'm going to start with x is 0, y is minus 6. So I'll go right here, and the slope is 2. So I'll go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And then I say, okay, it's a solid line because it's greater than or equal to. And I will put my little arrow up. And then maybe I'll use purple, and I will say, okay, I have a positive 0 and positive 6. So here we go. And the slope is minus 1. So down 1 over 1, down 1 over 1. Let's see. Okay. And then it is also a solid line. And I'm less than that. And so here is the region that is the solution. But in order to answer the problem, we have to find the vertices. And so what are the vertices? So they are 0 and 6, 0 and minus 6, and looks like x is 4 and y is 2. And then we need to evaluate f of x and y at those locations. And so this would be 0 minus 12. So that would be negative 12. And this would be 0 plus 12. So that would be 12. And this would be 20 minus 4, which would be 16. And so they wanted to know, find the minimum value of the function. So the minimum value of the function, oops. Is negative 12. Okay. All right, last problem. It's an optimization problem. And a company manufactures a football. We're going to call them X, baseball's Y. Okay, so I'm going to have my footballs are X's and my baseballs are Y's. Okay, footballs take 10 minutes to cut and 20 minutes to sew together. Okay, let's write that down. 10 minutes to cut and 20 minutes to sew. Come on. And baseballs, what do they take? They take 8 minutes to cut and 12 minutes to sew. And each day the company has 2 minutes total available for cutting. And so let's write that down. This is the maximum for cutting. This is minutes. And they have 3,500 minutes available. This is per day for sewing. Okay. Whoops, excuse me. Let's see. The company generates $8. So a football is going to bring in $8 of profit. And a baseball is going to bring in $5 of profit. There's a lot of information in here, right? Now we need to write in a system of inequalities. There's 4 of them. So he gave you some hints there that could be used to model the production and constraints of the footballs and baseballs. Now then we want to write a function that we're going to try to optimize because we're going to try to maximize. We want to optimize our daily profit. Okay, so this is kind of similar to well, we did problems like this in our notes. So first, let's do our system of inequalities. So if I know that I have a total, I cannot have any more than 2,000 minutes for cutting. So I have to be less than or equal to 2,000 minutes for cutting. Well, how much does it take to cut, how much time does it take to cut each one of those things? And notice that the football's an X and the baseball is a Y. So I'll come along here and write, oh, I don't know, let's use purple. We'll know that I have, let's say for a football, which is X, it takes 10 minutes to cut. So every time I have a football, I got to have 10 minutes. Plus, what's the baseball? It's Y. And how many minutes does it take to cut it? 8. And those added together have to be less than or equal to 2,000 minutes because they told me they only have 2,000 minutes available for cutting. Well, then let's do the next one. Let's come over here and look at sewing. So now we're working on sewing. So we need to have X times 20 plus Y times 12. And if I have only 3,500 minutes for sewing per day, I've got to be less than or equal to 3,500 minutes for sewing. Okay, now can I make negative amounts of baseballs or footballs? No, so X has to be greater than or equal to 0 and Y has to be equal to or greater than or equal to 0. Okay, so there's 4 inequalities. So that's the only thing that we have. Now, we want to set up a function that we might want to maximize. What are we trying to maximize? We're trying to maximize our profits, and profits have something to do with the number of footballs and baseballs that I've sold times the dollars of profits per each. So this function that I'm trying to optimize, f of x and y, oh, come on, that I want to optimize is equal to the number of footballs that I make times its profit, which is $8, right? Plus the number of baseballs that we make and its profit, which is $5. Okay, so there's my function that I would actually want to optimize if I were to solve this using this linear optimization approach that we've learned about. So I would graph those 4 inequalities, and then I would find the vertices, and then I would plug it into my function to determine which one was optimized, which vertices actually optimize that function. But it did not ask you to do that. It said do not optimize the function. So we have answered the question. We have 4 inequalities. So here's 1, here's 2, here's 3, here's 4, and we wrote the function f of x that can be used to determine the daily profit for the company. And there it is right there. Okay, that concludes my solutions for this quiz. Message me if you have any questions.